Hello students, my name is Shashank Shekhar. So let us continue with the exercise of solution. So 21st question says that there are two elements, namely A and B, which form compounds AB2 and AB4. So when they are dissolved in 20 gram of benzene, as the benzene formula is C6H6 we know, then 1 gram of AB2 lowers the freezing point by 2.3 Kelvin, whereas 1 gram of AB4 lowers it by 1.3 Kelvin. Therefore, what is the molar depression constant for benzene? And the molar depression constant is given it as 5.1 Kelvin kg per mole. We have to calculate the atomic mass of A and B. So what are the informations that are given? So let us take the first case of AB2. First of all, the mass of benzene is fixed. Mass of benzene is fixed and it is 20 grams for both cases. Now for AB2 is given having the freezing point, a lowering of, so delta T 2.3 Kelvin. And what else is given? The mass of AB2 is given. So mass of AB2 that is being dissolved is given as 1 gram. Then mass of AB4 is also 1 gram, but the lowering is 1.3. So we can say that for AB4, the delta TF is 1.3 and the mass that is being dissolved is 1 gram here also. Now what is being asked? We have to calculate the atomic masses of A and B separately. So for that, what we will do, we will calculate the molar mass, right? We will calculate the molar mass of both AB2 and AB4. And we are also given with the value of Kf. So Kf will be also constant for both cases because it is dependent upon the solvent. So it is 5.1 Kelvin kg per mole. Now if I calculate it for AB2, so delta Tf, we know the formula is equals to Kf m, where delta Tf is the depression in freezing point and Kf is the molar depression constant and m is our molality. So what about delta Tf? For AB2 it is 2.3. So it is 2.3 and Kf is common. So it is given as, so what was the value of Kf? It is 5.1. 5.1. What about molality? So it is number of moles of AB2. So let us assume that the number of moles of AB2 is m. So that would give us the number of moles as 1 by m. Okay, so we are considering the molar mass of AB2 as m. Okay, so let us consider that the molar mass of AB2 is m AB2. Okay, m AB2, whereas the molar mass of AB4, molar mass of AB4 is MAB4. Therefore, it would give us MAB2. And what is the formula for molality? It is number of moles by per kg of solvent. So what was the mass of solvent that we have taken? It is 20 grams of benzene, and we know that the mass should be in kg in case of molality. So 20 10 to the power minus 3. So from here, we can calculate, say, our MAB2. MAB2. So it would be 5.1 multiplied by 1 by 20 into 10 to the power minus 3, again multiplied by 1 by 2.3. And similarly for AB4, it would be 1.3 is equals to 5.1 into 1 by MAB4 divided by 20 into 10 to the power minus 3. That would bring us to MAB4 is equals to 5.1 into 1 by 20 to 10 to the power minus 3 into 1 by 1.3. Now, how we will calculate the molar mass of AB2? That would be atomic mass of A. Atomic mass of A. So I am representing it with A plus 2 into atomic mass of B. So that would be our molar mass. Similarly, here also it would be 4 into B. Now we have two equations, linear equations in two variable, and also we have two equations, right? So we will calculate this. How will calculate this? So let us write it again. So we have A plus 2B is equals to 5.1 into 20 into 10 to the power minus 3 multiplied by 1 by 2.3, and A plus 4B is equals to 5.1 multiplied by 20 into 10 to the power minus 3 multiplied by 1 by 1.3. Now if we subtract both of these equations, so this and this will be cancelled out, we will get here minus 2B is equals to, so if we take this thing common, that is 5.1 by 20 into 10 to the power minus 3 common, that would give us 1 by 2.3 minus 1 by 1.3. Isn't it? So let us solve it further. So minus 2B is equals to 1 by, okay, it was just 5.1 by 20 into 10 to the power minus 3. So if I would subtract 1 by 1 by 2.3 minus 1 by 1.3, that would give us 1.3 minus 2.3 by 1.3 into 2.3. Okay. Further, minus 2B is equals to 5.1 by 20 into 10 to the power minus 3 multiplied by, so this minus this would give it minus 1 divided by, so 13 into 23. How much? 13 into 23 would be, so 13 3 is 39 and 13 2 is 26. That is 299 or 2.99. So this minus and this minus will be cancelled out. That would finally give us 5.1 into 10 to the power 3. I am bringing this 10 to the power minus 3 upside, divided by 20 into 2.99 into 2. Yes. So if you just solve it further, so it would be 5 from here, and this will be cancelled out. So 51,000 by 4 into 299. So this would be our atomic mass of B. Now once you got the atomic mass of B, you can just substitute in any of these equations to get your atomic mass of A. So let us see the solution now. So we have used this formula, M2 is equals to this much. Okay, we have calculated MAB2 with the help of this, and MAB4 with the help of this. Next, what we have done, we got two equations, this and this, and further we find the value of y and x, and therefore the atomic mass of A and B upon calculation we will get it as 25.59 and 42.64 U. Next question, what does it says? So the question says that at 300 Kelvin 36 gram of glucose is present in a liter of its solution, has an osmotic pressure of 4.18 bar. If the osmotic pressure of the solution is 1.52 bar, at the same pressure what would be its concentration? So how we'll calculate it? So first let us look at the next situation. So it has been asked that if the osmotic pressure is 1.52 bar, then what would be the temperature? What would be the concentration if the temperature is same? Now we can first have first the temperature is given as 300 here. Okay, 300 here, and next thing that is being given is your R. We know R, it is 8.314. So we can calculate the concentration from here. Okay, we can calculate the concentration of here. So very easy, just pi by RT, that would give us 0.061. Next is suggest the most important type of intermolecular attractive interaction in the following pairs. So we have to see that suggest the most important type of intermolecular attractive interaction. So in this, what type of interaction would be the most important we have to suggest? So it would be van der Waals force. Van der Waals force, isn't it? In case of IClF4, we will have which type of interaction? Say in NaClO4 and water, it will be hydrogen bonding. So in methanol and acetone, which type of interaction will be present? And in acetonitrile and C3H6. So let us look at the answer. So van der Waals force, we have ion dipole interaction, dipole interaction, and here also dipole interaction. Based on the solute solvent interaction, arrange the following in order of increasing solubility in N-octane. That which of these will give the higher solubility? So first, N-octane and cyclohexane, so both are non-polar, so therefore they will have high solubility. KCl will have low solubility. CH3OH will have, say, I think cyclohexane will be the first one. So if I name it number A, B, C and D, then A will have the highest solubility and B will have the least solubility. Talking about C and D, so which one is more polar? So it is very obvious that C is more polar, so C will be here and D will be here. So therefore, cyclohexane, then methyl cyanide, then your methanol, and then potassium chloride. The same order is there. So we have cyclohexane, KCl, so CH3OH. Yeah, sorry, this is the order. Okay. So this is the solubility order as I have told you, then methanol, then CH3Cl, and then cyclohexane, because the polarity order is reverse. Amongst the following compound, identify which are insoluble partially and partially insoluble and highly soluble in water. So the one with the dipole moment will have highest solubility. The one with less polarity will have the minimum, and one with no dipole moment will have the maximum insolubility. So toluene will be insoluble, okay, and your chloroform will be insoluble, whereas your pentanol and say phenol will be partially soluble, and your formic acid and ethylene glycol will be highly soluble. So phenol and C6H5, thus phenol is partially soluble. Toluene has no polar group, that is insoluble in water. Formic acid, therefore it is highly soluble in water. Okay. Next is ethylene glycol, OH group and can form hydrogen bonding. Third, it is highly soluble in water. As I have told you, chloroform is insoluble, and pentanol, but it is also contain very bulky group, so it is partially soluble. What is the next question? If the density of some lake is 1.25 gram per liter, the density is given. So if we convert it into gram per liter rather than gram per milliliter, then it would be 10 to the power 3 gram per liter, and contains 92 gram of Na. 92 grams of Na. Mass of Na is 92 grams. That is per kg. So if we divide this by its atomic mass, then that would give us the molality. Okay, because it is a mass of iron dissolved in per kg. So if we find the number of moles related to it, then it would be your molality. 92 by 23 will be your molality. Then further we have to calculate its molarity, not molality. We have to calculate the molarity. So if you multiply the mass of water with its density, Then we will get the volume. So volume will be equals to volume of 1 kg of water or 1 kg of solution would be 1.25 into 10 to the power 3 liter. This is the volume. What is the number of moles? Number of moles in that 1 kg is 92 by 23. So therefore molarity is easy to calculate. It will be 92 by 23 multiplied by 1.25 into 10 to the power 3. Calculate this, you will get your answer. So first number of moles, okay, and hence the molarity. If the solubility product of CuS is 6 into 10 to the power minus 16. So the solubility product is given, therefore solubility into solubility is given as 6 into 10 to the power minus 6. Therefore concentration of, I would say that concentration of either Cu plus or S, so it would be Cu2 plus and S2 minus, is nothing but 6 into 10 to the power minus 6 root under. Okay. Now calculate the maximum molarity of CuS. We have to calculate the maximum molarity of CuS. So maximum molarity means the least number of, say, the least volume we can take and the max number of moles we can dissolve. So it would be simply root under this, but if we take the least molarity, what would be? So first it's calculated S square. So that would be the least molarity. Okay. So this is the least molarity. That is 2.45 into 10 to the power minus 8. Sorry, maximum molarity. Okay. Calculate the mass percentage of aspirin in acetonitrile when 6.5 gram of this is dissolved in 50 gram of CH3Cl. So very easy to calculate the mass percentage of aspirin. So mass of aspirin divided by total mass, that is 6.5 plus 450 into 100. So same thing is done, 6.5 by 456 into 100, that is 1.424%. So this was your last question. With this I end my lecture. Thank you.